anytime, science is essential. Everywhere, all the time, science boosts your potential. Knowledge equals power. Don't waste another hour. You can do it. Anywhere, anytime.
This program was funded in part by the Pick Hour Foundation and the Bank of America Neighborhood Excellence Initiative.
10 seconds to go. Okay, there's pitch over. Right there it is. Right on the money. Right on the money. That's beautiful. Right out the window, just like outstanding. There's Houston. Here, go for landing. 40 feet. 3 feet per second. 30. 3 feet per second. Looking great. 20 feet. 10. 3 feet per second. Contact now. 2, stop. Auto. We're on the surface. Okay, we made a good landing. Roger, enter.
Only 12 people, like the astronauts on this Apollo 14 mission in 1971, have actually walked on the moon. But scientists have been studying it for centuries. We can all see that the moon appears brighter than the stars in the night sky, but what makes Earth's neighbor so important? When we want to know what time it is, we look at a watch or a clock. But there's a way to tell the passage of time without them. We know that the moon orbits Earth every 28 days, so we can measure time by its movement. We always know when it's daytime or nighttime because of the rotation of Earth. It is daytime on the area of Earth facing the sun, and it's time for bed when that same area faces away from the sun. Earth's orbit around the sun creates our years, and the tilt of Earth throughout the orbit creates the seasons. But even though the moon is 384,000 kilometers away and only about 1/4 the size of Earth, the moon does much more than just help us keep track of time.
The moon orbits about the Earth because of the Earth's gravity, much like the planets orbit about the sun due to its gravity.
The moon affects our tides with its gravity. And the moon can give us light at night, but the moon doesn't actually produce that light.
So when we see the moon in the sky, it is because it's reflecting the light from the sun itself.
And whenever the moon seems to shine because of the sunlight bouncing off it, we always see the same side, because that side is always facing planet Earth. So how big is the moon anyway? If the moon were the size of a penny, how big would Earth be? Have you ever wondered what it would be like to walk on the moon? There's a lot less gravity on the moon than on Earth, so everything, and everyone, feels much lighter. Edgar Mitchell was the 6th person to walk on the moon.
The physical sensation is because you're in reduced gravitation, 1/6 gravitation. It's like walking on a trampoline because the 1/6 gravitation makes you pretty light.
There's almost no atmosphere on the moon, so astronauts needed to wear a lot of protective equipment.
Because you're in a pressure suit, which is pretty stiff and cumbersome, I like to say it's walking on a trampoline but with 6 overcoats on because it's so stiff you can hardly move.
The very thin atmosphere of the moon has no wind or water except for a tiny bit of ice on the poles. And the surface of the moon is much different than Earth. It's dry and dusty, much like baby powder. So the footprints left by Apollo astronauts years ago will still be there millions of years from now. The surface of the moon is dotted with impact craters, which we can easily see from Earth. They were formed when meteoroids and comets crashed into the surface many years ago. Here, we are simulating the impact of meteoroids by dropping stones into a container of wheat flour covered with cocoa. We can see just how those craters were formed. The moon has lowlands and highlands. The highlands, which are lighter in color, are known as terrae. Comets and meteoroids crashed so hard into some places on the moon's surface that magma from the core flowed out. That magma cooled to lava, which formed low, flat plains that very early astronomers mistakenly thought were bodies of water. So they are called maria, which is Latin for sea. Though they were formed long ago, the craters on the moon still exist because, remember, there is no wind or water to wash them away. We have impact craters here on Earth, too, but strong winds and rain have made many of them disappear. Some craters even filled with water and became lakes. Since the moon has no wind and no rain, is it possible for an astronaut's footprints to disappear from the moon? The moon appears to move across the nighttime sky. That's because of Earth's rotation. Earth rotates once every 24 hours. But days on the moon are much longer than days on Earth. The moon rotates only once every 28 days. That means one day on the moon lasts 14 Earth days, and a night lasts 14 Earth days. So imagine if people tried to live on the moon. To stay on the same 24-hour schedule we have here on Earth, they'd have to sleep during some of those lunar days and work during some of those lunar nights. We also know the moon revolves around Earth during those same 28 days, and that's how we can tell the length of each month. But since the moon takes the same amount of time to rotate and revolve, the same side of the moon is always facing Earth, and that created a mystery.
Until spacecraft were sent around the backside of the moon, we never knew what it looked like.
But now we do. We have pictures of a rough and rugged moonscape that's loaded with craters. And when astronauts flew around the moon, they could see the part of Earth that was lit up by the sun, the part that was in daylight.
That's an utterly magnificent view, and particularly from lunar orbit, when you come around from the backside of the moon and you see Earthrise coming up over the horizon of the moon.
We can see the moon from Earth because it reflects the sun's light. Those astronauts who landed on the moon could see Earth for the same reason.
It looks like a little orb, just about like a full moon looks from us here on Earth.
But the astronauts could not see the part of Earth that was in nighttime, because there was no sunlight to reflect off that part of the planet. If the same side of the moon is always facing Earth, what is on the far side of the moon? As the moon revolves around Earth every 28 days, the half facing the sun is lit by sunlight, just like the half of Earth facing the sun. During the revolution of the moon around Earth, different parts of the moon get sunlight. We only see the parts of the moon that are lit by that sunlight. When the moon is exactly opposite the sun in Earth's sky, we see the whole side of the moon that's lit up. This is called the full moon.
And what does that make me? The man in the moon? I don't think so.
The moon then begins to lose some of its sunlight, at least on the part of the moon that faces Earth. This phase is called the waning gibbous moon.
Okay, I have two problems here. Waning and gibbous. What are those words all about?
Waning means diminishing or becoming less bright. In this case, less sunlight is hitting the part of the moon that we can see. Gibbous means curving or bulging outward, which is really how the moon looks in this phase. After about a week, we can see the last quarter moon. It looks like a half circle.
Hello? I have another problem here. The moon looks like a half circle, so why is it called a quarter moon?
This phase is called a quarter moon because from Earth, we can only see 1/4 of the moon's total surface. The far side of the moon is also in the dark. The waning crescent moon looks just like a sliver of the moon in our sky.
I remember waning means diminishing, but that crescent moon looks more like a banana than a crescent roll.
Good point, but it's not a banana moon. It's still called a crescent moon. And here's what happens when the moon is in between Earth and the sun. Only the far side of the moon is lit up, and we can't see that side from Earth. It's called the new moon, and it happens about 2 weeks after the full moon.
I'm glad you told me I can't see a new moon. I thought I was having trouble with my eyes.
As the moon revolves around the rest of its orbit, it becomes more and more visible during the waxing phases. Waxing means a gradual increase, and that describes the sunlight as it lights up more and more of the moon during its first quarter and then waxing gibbous moon. And then it's back to a full moon about 28 days after the last full moon. So imagine, if the moon is full tonight, what phase will it be in 2 weeks?
Moon phases beginning.
We like to watch the moon, it's such an awesome sight. And when it's called a full moon, it looks so bright.
For it to be full, it's opposite the sun. The moon is like my baby, it's so much fun. As the light gives way, the moon begins to wane. It's a waning gibbous moon, yes, a moon with a funny name. It's more than half full and less than fully lit, so it's beginning to wane, and that's about it.
Last quarter moon, the name is quite confusing. It looks half lit, and that's a bit amusing. But looking at the moon, you only see a quarter of the total moon surface, which is what you ought to.
Phases of the moon. There's so much cool stuff that you never knew. We're gonna watch it wax and wane. Get ready for this knowledge coming to your brain.
When you look again, you see a sliver in the sky. It's a waning crescent moon about to say goodbye. It looks like a banana and good enough to eat. It's a waning crescent moon, so take a seat.
The next phase is the new moon, and when it comes to call, it's very, very secretive and can't be seen at all. The sun is only shining on the far side of the moon. There's no light for us to see it, but we'll see it real soon.
When it starts to wax, it's a waxing crescent moon. It gets our hearts a-thumping as it sings a growing tune. Then it looks half lit as the first quarter appears. It's like the last quarter getting bigger, that's clear.
We're gonna phases of the moon. There's so much cool stuff that you never knew. We're gonna watch it wax and wane. Get ready for this knowledge coming to your brain. One more phase.
The Jesus moon returns, and now it's really waxing. Trying to learn gibbous can turn out really taxing. It's more than half full and less than fully lit.
It's almost finished waxing, and that's about it.
Moon phases complete.
Here we are at new moon. The moon is on the same side of the earth that the sun is, so people on earth can't see any of the lit up portion of the moon. They only see darkness. And this is the time of the moon phase that we really can't see the moon. We're going to move a quarter of a turn around. Go ahead, moons, and move a quarter of the turn around. Very good. Now you guys are at first quarter, so half of the face of the moon is lit up, and half the face of the moon is in darkness. half the face of the moon is lit up and half of the face of the moon is in darkness. Moons, you're always watching the earth. Your face is always pointed right at the earth. The earth always sees the same face of the moon. Let's go a quarter of the turnaround to full moon. Okay, so now it is full moon. The entire face of the moon is lit up. The face is still pointed right at the earth, but we see all of it lit up by the sun's light. Let's go a quarter of a turnaround, and we're going to go now to third quarter, where again we're at a point where half of the face of the moon is lit up and the other half is in darkness. And finally, let's go back to the beginning point at new moon, where the entire face of the moon is in darkness.